Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To synthesize hexanol, a 6-carbon aldehyde, CH3CH2CH2CH2CH2CHO, we need a reliable method that builds the correct carbon skeleton and installs an aldehyde at the terminal position. Step-by-step analysis of option D. Moving on to the next step. CH3CH2CH2CH2NGBr, butyl magnesium bromide, a Grignard reagent, reacts with ethylene oxide, H2C, CH2 with an O bridge, i.e., oxiding. Grignard reagents open epoxides via nucleophilic attack at the less hindered carbon. Butyl Grignard attacks the terminal carbon of ethylene oxide, adding to carbons and yielding, after workup, a primary alcohol, CH3CH2CH2CH2CH2CH2O, 1-hexanol, weight, that is a 6-carbon primary alcohol. Moving on to the next step. H3O plus workup protonates the alkoxide to give 1-hexanol, CH3CH2CH2CH2CH2CH2O, a primary alcohol with 6 carbons. And for the final step, PCC, pyridinium chlorochromate, in CH2Cl to oxidize a primary alcohol to an aldehyde, but not further to a carboxylic acid. 1-hexanol is oxidized to hexanol, CH3CH2CH2CH2CH2CHO. This sequence cleanly gives hexanol in 3 steps with correct carbon count and functional group. Why other options fail? Option A, CH3CH2CH2CH2Br plus NaCCH gives a terminal alkyne, 1-hexyne, 6 carbons. Markovnikov hydration with H2SO4HgSO4 of a terminal alkyne gives a methyl ketone, 2-hexanone, not hexanol. This gives the wrong product. Option B, epoxidation of 1-pentene with peracid gives 1,2-epoxypentane, 5 carbons. CH3NGBr opens the epoxide to give a 6-carbon secondary alcohol, to hexanol after H3O plus workup, and PCC oxidation would give to hexanone, not hexanol. Wrong regiochemistry. Option C, starting with 2-hexanone, Baeyer-Villiger oxidation with peracid inserts oxygen to give a 6-carbon ester, hexanoate ester. Lyell-4 reduction of the ester gives a primary alcohol, 1-hexanol or mixture. PCC oxidation gives hexanol. This sequence is longer, 5 steps, and less efficient clean compared to option D. Additionally, Baeyer-Villiger on a methyl ketone preferentially migrates the larger group, so the product would be pentyl formate or methyl pentanoate depending on migration, making the carbon count and product less straightforward. This is not the best synthesis. Option D is the most direct, efficient, and reliable synthesis of hexanol. Therefore, the correct answer is D. Therefore, the correct answer is option D.